Okay, g'day students. Welcome to the lesson. We are starting to look at paying off home loans now. So this is quite an important topic for your life, I suppose. It's getting harder and harder to get home loans because houses are getting more expensive in Australia. So what that generally means is you're going to have to pay more money and probably over a longer period of time to be able to calculate your home loans or to pay off your home loans. So what we want to do today is just use our recurrence relation to determine your monthly home loan. So we'll use this to model a reducing balance loan. That's where your balance reduces to zero and you've paid off your loan. And then later on we'll look at the changes of interest rates and repayments amount on the time taken to pay the loan. And then we'll look finally at using this lesson, I suppose, Excel in help determining when a loan is paid off. So some important terminology. Our recurrence relationship for a reducing balance loan looks like this. Now this is it in your formula book, this is it in your textbook. So the big difference is that your textbook is just using the L for loan, whereas your formula book will just have A for amount. Now that, if I look at that then, so I'm just saying that the growth factor, which is R, is what determined by the interest rate quoted, and that's generally per annum, but you'll have to express it per compound period, multiplied by the outstanding balance, so that's the A sub N, and then minus the repayment, and that will give you the amount or the outstanding balance at the end of the next year. So if I look at a reducing balance home loan, the account balance after the first repayment is just calculated by the first reduced balance. It equals the borrowed principal plus the interest minus the repayment. Now that's the same as saying the first reduced balance equals the borrowed principal minus the principal portion. So reducing balance home loan is calculated after the bank adds interest on the outstanding principal, so it's the principal plus the interest minusing the repayment to get the actual outstanding balance at the end of the compound period. Now to do this, you're going to amortize your loan, which just means to make these regular equal repayments to pay off debt. And a balloon is sometimes there, for example, in car loans, is a final repayment and can be a substantial amount of money to pay off that loan. So if you're taking out a car loan with a reducing balance loan, read the instructions carefully or the contract carefully to see if there is a balloon. Okay folks, let's have a look at a typical home loan. So if I'm looking at a typical home loan, it's something called a reducing balance home loan. Essentially you might pay off something each month. This is called a repayment. So but the bank will also charge you interest, for example, each month or each compounding period. And it will charge you on top of your principal. So what's going to happen is that each month your bank will charge you interest and you're going to be repaying off a loan. So let's have a look at an example of a reducing interest home loan. We'll just use the terminology from the textbook here. And we'll also compare it to the appropriate one in your formula book. So if I have a look first of all at your formula book, your recurrence relation for reducing balance home loans is the amount after a number of years equals the rate and then the amount at that year, the year beforehand, minus the repayment. So we should have a look first of all at the initial borrowing, which is the first one, so that would be my AO in this case, or in your textbook it will describe it like this. LO is the principal. Now the loan amount after a compounding number of compounding periods, and then LN plus 1 equals the growth rate times the loan amount, so LN minus the repayment. And let's see what this means. So we'll go with this one here. So AN plus 1 equals the growth rate of A minus R. Now After the first period, for example, that would just be AO minus R. So let's have a look at this example and see if we can consider this now. So our AO, remember, will be our principal, and our repayment will be given to us in our question. So with the principal, and we'll have to determine the growth rate. So a loan of $10,000. So we have a loan of $10,000, 10,400. So straight away we can see that, yes, that's got to be, in this case, AO. To be paid with quarterly repayments of $420. Well, here's our $420, and that's going to be our capital R. Now, interest is charged on the loan balance at each quarter at a rate of 6% per annum. So per annum, well, we're going to write a recurrence relation for this loan, and we just note that it's quarterly repayments. So in this case, I is going to equal, well, 6% is 0.064 over 4 quarters in a year. Well, that's going to give you an O of 0.16, and therefore your rate is going to be 1.016, just to add the 1 on. So what shall we do first of all? We'll write this as a recurrence relation. So all we need to do is to consider that in this case, the AO was what? $10,400. The amount at the end of any particular term, so just A n plus 1 equals AN. And what was our growth rate? Times 1.16. So I'll put the 1.016. So I'll put that first, 1.016. Now AN, and we'll do our calculation for the first one. And so now we just do the 420. Just want to highlight this for you. Our growth rate here is this. So this is the amount that it's actually growing. So we're just plussing on the interest there. Our repayment is here. And then, for example, if we want to calculate the principal after the first period, that could be that one if it's AO. So let's do this one. So we'll go A1 equals, well, what's the growth rate? It's 1.016 multiplied by 10,400 minus 420. So I'll plug it into our calculator and I'll give it a crack. 1.016 multiplied by 10,400. Generally do an equals there. So you can see that, yes, it has grown. Take 420. So the amount at the end of the first compounding period is 10,146 and 40 cents. So what you will see is this interest will actually be reducing each time we do it. So I'm just going to express this, how we might do this, as you see on a bank statement as well. So we can just write it as account balance, yes. Now, what was our principal? It was $10,400. Now, to calculate the interest, or the growth rate, it's just going to be plus PIN. It's a simple interest, and then we're going to minus that repayment. Now, that repayment, I told you already, was what? $420. So we know that the principal, and we know the repayment, so I did the repayment in blue, so let's do that. And now let's just consider this growth rate as a plus value. And we're going to see that this is going to change each month. And I'll do that with you soon. So 10,400. Now PIN, well, it's just principal, 10,400 times the interest. Well, we worked out our interest back over here. It was just 1.016. So remember, it was 6.4% per year, and we want to turn it into a quarterly amount. So, and then we just plus 1 for the growth factor. And then finally, N will equal 1 quarter, and then minus that 420. So I'm particularly interested now at how this changes from term to term. So 10,400. So just working in that middle section now. And what have I done wrong? I don't need to put the 1 in because I'm just looking at a growth rate. I'm just looking at interest. Okay. Yep, that's for 1 quarter. That looks good. So it's saying minus 166 and 40 cents. I should put a plus in. Follow the formula through properly, Mr. Beasley. 420. And that's good. And that should get us the same value. So let's do that. 10,400 plus an interest of 166 and 40 and minus 420. And 10,146 and 40 cents, and that's the same, so that's nice. Rightio. So let's now have a look at what we mean by reducing balance. And I'm going to do this first of all using this method here. And I'm going to particularly look at this interest term here in green. And I'm going to explain it using the above formula first of all and this strategy here. So we worked out after 1 compounding period, this loan was now reduced down to 10,146. So at the start of the second compounding period, okay, so A2, we had a principal now of, what was it, 10,146. So this becomes our new principal. So let's substitute that in. So it's 10,146. It's doing weird things again. And 10 cents. And we're going to go, well, plus PIN. And minus that repayment of 420. And as I said, I'm really just interested in this PIN term. Now, what's interesting here is this is a reducing interest. And the point of this is to notice that this overall term is going to be reduced because the principal has been reduced. That's the principal. Okay, so let's do our calculation. We've got 10,146 and 10 cents plus our principal now of, our interest calculation of PIN 10 10,146 and 10 cents. Sorry, 40 cents. I copied that incorrectly. And 40 cents. Now, remember the interest was 6.4% per annum, so that's 1.6% per compound. We're just doing it for one compound and then for 20. We're just doing the interest calculation at the moment, so it's 10,146 and 40 cents multiplied by 0.16. So that's 162 and 34 cents. And that's just going to be 10,146 and 40 cents, and that's going to be minus 420. So I'll calculate that now, and we'll just explain quickly why this is also called a reducing interest. Okay, so we're going to plus that 10,146 and 40 cents, and then take away the 420. 9,888.74. So this is called a reducing balance or a reducing interest loan, and as you can see, there are important reasons for here. So that's going to, where's my highlighter? I'll use a different colour. So the amount at the end of the second compounding period is 9,888. So that's our principal, or the amount owing. So that's the balance owing on the loan. So at the start of the loan, it was 10,400. First compound in, it was 10,146 and 9,888 at the end of the second term. End of the first term, start of the second term. I also want to look at this. This is also called a reducing interest loan because the interest payment has gone down as well. So 166 down to 162. Okay, here I am in Excel, and I'm just looking at reducing balance home loan again. And we've got this example of Gemma here. She needs to pay $22,350 for home repairs. Now, the bank has offered her a loan with interest calculated 6.6% per annum charged monthly with a reducing balance, reducing account balance. So she's going to make repayments of $550 per month until it's completely repaid. So first of all, let's write this as a recurrence amount. So now, principal, if I could spell, I'd be dangerous. Principal. Now, what did we say that was? That was A0. I wonder if I can do a subscript on this Excel. So let's go. Let's see if I can select that and just go Control equals to subscript it. No, that's not going to work. Anyway, so what's our principal? That is the initial amount that we're borrowing. So let's, can I draw? Yes, I can draw in Excel. So that's got to be that one there, hasn't it? That's got to be the initial amount. Now your textbook, remember, will call that LA for the loan amount. So $22,350. Now, what else do we need to know? We need to know our growth rate. Now, our growth rate, remember, is 1 plus the interest rate. So it's 1 plus I. Now, that interest rate has got to be calculated. In this case, it says 6.6% monthly, but per annum, but it's charged monthly. So we're just going to say, well, I equals, let's say equals 1 plus because it's growth rate, and then we're going to go open brackets 6.6%, which is 0.066, and it's charged monthly, so it's going to be divided by 12. So we've got a growth rate of 1.0055. Does that look right? Yeah, a twelfth of that. That's got to be pretty small. So may as well just put an equal sign there just to make it look nice. And actually, what else do we want to do? We also need to calculate the repayment. So what are we saying? We've got a repayment of $500. Or I should do a capital R for that. And that's 500. So let me write out a recurrence relation and let me see if we are doing this all right. So our recurrence relation is what? N or N plus 1. Oh, this is really not nice. N plus 1 equals the growth rate multiplied by N minus the repayment. That's pretty sketchy, sorry there guys, but let's set this up in a spreadsheet. So what we need to consider is, first of all, the number of compounding periods. So we'll do the start. The start, remember, was 22,350. Now, this should be our balance. And now it's charged monthly. So let's just continue this down for a while. Down to 25. We'll probably do more of that. Now let's calculate this. So all we do is go, oh, okay, our growth rate is that, isn't it? So I'm just going to type that in today because I don't plan on changing it. So it's 1.0055. Now it's multiplied by, so in this case I need to use an asterisk to multiply and multiply by that. So there's that bit first, and I'll need to put all that in brackets because I'm working in Excel, and then I'm just going to take away that repayment of $500. I should just make that pretty with the formatting. So that's all in more money formatting now. And let's see how this reduces. So, and I might just continue until I can see where it hits 0. Whoops, okay, so I've gone way too far. So, there we go. So after 51 months, now 51 divided by 12, so that's 4¼ years. So after 4¼ years, this loan is repaid off. Now maybe I should just note that it's paid off in the 52nd month of the loan. So it's probably more accurate to say 52 divided by 12, and a third of the year, well, third of 12 equals 0.33 times 12, so 4 months. So loan is paid off after, what do we say, 4 years and 4 months. What else should we do? We should probably graph this as well and just note the shape of the graph. So let's do that. So I'm just selecting here, and I'm going to insert XY scatter is the best one, and you should note that the graph is a bit of a gradual curve. Okay, and that'll do for the moment. So today, folks, we've looked at reducing balance home loans. We've expressed them as a recurrence relation, as you can see in this expression over here, which my pen is not really flash at the moment, to model that reducing balance home loan. And we've just investigated it using technology, a basic example. When you're happy with that, please work on the mastery questions.